Welcome back. Welcome back. Come in. It's great to see a pretty full room. Hope you all had a great lunch, a great break, had a look at some of the exhibits, networked. But welcome back to the main stage. I should say, just a reminder that we have a Zetane Systems workshop starting right now in track 3, which is called Can It Be Done? 1 hour to ship a robust and explainable real-world AI product. So, if that's of interest, go over to track 3. You're in the wrong place. But hopefully you're here to see our next speaker. We're kicking off with Sreedhar Sistu, who is the Vice President of AI Offers at Schneider Electric. He's going to share his knowledge around how to use AI for sustainable impact. Sreedhar is a senior software and product executive and a leader with extensive experience in product strategy and growth, portfolio planning, cloud architecture, DevOps, large-scale deployments, offshore management, and program management. So, without further ado, over to you, Sreedhar.
All right. How is everyone doing? The post-lunch is always the hardest one, both for the audience and for me. So hope we can bring some energy into this discussion. Just as a quick note for the AV team, looks like I'm seeing both same screens in case you're thinking about it. I'm supposed to have a speaker on one side and the main on the other, but we can work with it. Okay, so the focus of my talk is going to be on how to use AI for sustainable impact. You've heard a lot about AI, and there are lots of people, lots of things that we can do. But I think this is one of the important areas where I think we can make meaningful impact with AI in both ways. And we'll talk about some of the impacts that AI might have on the energy itself. It works. So just as a quick introduction, so I work for Schneider Electric, and our focus is really to empower everyone, on the energy and sustainability, how to use the energy resources effectively, and so we can all be more sustainable. And as you know, the needs are growing. Now, if you think about sustainability, it all boils down to using the amount of energy. And we can do it in a couple of ways. We can all try to just reduce the consumption. We, stop consuming. We can reduce maybe the growth that we have, which is probably not the path that we want to take. And the second one is, how do we optimize the type of energy that we consume, and also favor the types of resources that are more sustainable. If you think about it, today, just to give you some, bit of statistics on this, the energy demand in the world is about 25,000 terawatt hours, and it's growing at about 1.3, 1.4% every year, just based on the population growth and kind of things that we want to do. We weren't watching those many streaming videos before, and streaming videos do consume energy, right? Smartphones, billions of smartphones around. And the other part is we are also getting huge number of new loads. So what I mean by that is we have electric vehicles that are coming onto the grid that are going to have a significant impact. And then we are also going to have lots of data centers. Data centers are the factories of 21st century. Everything that enables us to communicate, to have video streams, to have, sharing pictures with everyone, have the communication, that's all powered by data centers. And they are growing. And the other thing is, a lot of energy that is produced today is also still not the most sustainable one. We still use a lot of fossil fuels for consuming energy. Yes, we have solar energy coming, but those of you in the energy industry know that it's one thing to install solar panels, it's the other thing to actually connect it to the grid. So there's a huge gap, we call it the interconnection queue problem. Then there is also, we know that the impact on the climate. Last year was, we had this goal of 1.5 degrees. We think we are still under this 1.5 degrees. For those of who are not in the know, it's 1.5 degrees is the target that we set, that the temperature pre-industrial era Earth temperature to something that is sustainable. According to some reports, we have already crossed that last year. A good number of months it was above 1.5 degrees. And given all of this, the picture is pretty bleak, right? I mean, energy demand is growing. We are using fossil fuels. We cannot connect the renewable energies, and so we are kind of doomed. But I think the other way of looking at this is we have a lot of technology available today that can help us reduce the energy needs and make us more sustainable. And my focus of the discussion today is AI is a critical component of that. I mean, there have been lots of things, digitization, setting up new equipment, etc., but I think AI is going to be a critical part of it. So I look at the energy, and AI in three broad areas. The first one is really reducing. So you really try to cut down the energy through various kinds of efficiency measurements that we can do, and I'll talk about that, specific examples. And then optimizing the energy mix, so we are not just focusing on the ones that are most polluting or the ones that are most environmentally damaging. And then the last one, which is kind of hard to explain, it is really the overcome the barriers to adoption. Because as much as we might have technology, there are still lots of barriers to adopt, and that's what we want to overcome. So if you think about, optimization or reducing the energy consumption through AI, there are many places where AI algorithms are capable of reducing energy consumption by as much as 20%. Take large buildings HVAC. So in Western world, of course, heating is the biggest problem, and if you go to a little bit further down, cooling is the problem, and heating is obviously much more expensive than cooling. Nonetheless, we know that we can reduce the energy consumption of large buildings in HVAC systems by as much as 20% by applying smart algorithms that do a few things. Things like they can optimize the start and stopping. When to start the HVAC system, when to stop it. If people are going to be leaving office at 5 p.m., you can start to slow down before. You can also modulate the set points so that you maintain the comfort level. You're not compromising on that, but you can still reduce the energy footprint, because the basic set points that you have, like your home thermostat, are not good enough. And then there are similar things can be applied to other things, whether it is water desalination. As you know, we have places in the world where fresh water is not readily available, and desalination is the only way to do it, and desalination is an energy intensive process. And I think by using AI, we can reduce the energy needs of these processes. And then there are lots of industrial processes, whether it is in glass making, steel making, etc., that have traditionally used fossil fuels, and now they can use electricity and they can use energy in an optimal way. A concrete example that I can share with you is something that we have done is at a district heating system, that a customer that works with us in Croatia, which is serving over 8,000 customers. Here we applied AI-based forecasting system, so you can get a much precise forecast of the energy demands compared to a more traditional, guesstimates or a very simple moving average, type of estimates. That helps them dramatically reduce the energy consumption, because they can then plan the energy needs better. They can they can also reduce the cost because they can enter into better contracts, with their providers. So there is an economic benefit to that, and it's not rocket science. I mean, it is forecasting. I'm not talking about super complicated deep neural network models. These are, simple forecasting models that can have a significant impact on that. The second, area which is really close to my, heart is the change in the energy landscape. This is what I talked about, optimizing the mix of energies. So the energy landscape itself is changing, okay, significantly, because there used to be a time when what we call as a unidirectional grid, right? So you have energy that comes from the grid, you plug it in, and you get energy. Now what we have is we have distributed energy resources. You can have a solar panel on your rooftop that can produce energy. You can have a battery backup that is storing energy. And there can be, if it's a commercial building, there might even be a generator. So what we can do is, by using this mix, we can really try to reduce the load on the grid completely and also favor the ones that are least polluting. So if you have a solar panel that is producing energy, you can probably favor that much more. And even better, if you have you have an on-site production that you just want to use only that, by reducing the energy consumption, you can even do that. I mean, that's more extreme cases, which we call as, islanding cases. Interestingly, I'm just coming off of, another conference that was focusing on, what we call as microgrids, which solve the exact same problem. And these are the big, items on the agenda of government these days to increase the adoption of microgrids. And AI is at the heart of microgrids. So again, as a specific example, what I can share here is a customer that we work with, who is really focusing on, it's a building, it's a shopping center, and they had strong net zero goals. And the way that they can attain these net zero goals is by using one of our softwares. It's called a Microgrid Advisor, but I'm not talking about the software itself. But the key point is how we can manage the schedule of the energy and the consumption so that they can reach the net zero goals. And this is done on a continuous basis. And to explain why we need AI, traditionally we had a simple rule-based system that you switch this at these levels, etc. What AI can do is it can forecast both the demand and the production and then adjust it every 15 minutes so that you are closely tracking the curve of the demand with the least expensive energy that is there. The next area that is a little bit as I said, confusing, but very, very important is how to eliminate barriers to this adoption. So we know that the technology exists today, and we have demands coming from customers, but many times the problem is adopting these things. People have habits. As long as there is friction, it's very difficult to adopt new technologies. And AI can help in adopting these new technologies. So an example that I have that we work with one of our partners is it's a Qmerit. It's a company that is really focusing on increasing the EV adoption by installing electrical chargers at home. When you buy a new electric car, you can go through the process with Qmerit to do that. What we have done is you can use computer vision to very easily identify the potential to upgrade an electrical panel to install EV charger. Traditionally, it would have taken a contractor to visit the home and then assess what needs to be done. Now it can be done on a smartphone with a simple picture. They can make a first. This is not going to be a perfect answer, but for most basic needs, you can take a picture, you can assess whether it is possible to install an EV charger or not. This reduces not only the visits, but also reduces the effort and errors. Many times, when people come, there are less trained people, who might be making some mistakes in doing that. So this is but an example of what is possible, with AI in reducing the barriers in the electrification journey. So to kind of quickly summarize what I've been talking about, in order for us to achieve the sustainability goals, AI is going to play a significant role. And more importantly, in both reducing the overall energy needs and improving the mix of energy that we use, and also reduce barriers to that. And by the way, I've not talked about Gen AI, and this is obviously on top of everyone's mind, what this is going to do. Gen AI is going to play a huge role in this, the transition, where there is a lot of unstructured information, business processes are complicated, something that we can do. So with that, I will pause here and turn it over to some questions.
Thank you very much, Sreedhar, for that talk. And we are going to open this up for questions, I believe. So if you have a question, I spotted this lady already, very quick off the mark there, good work. Keep your hand in the air just so our roving mics can see you. We have a lady directly in front of me here. So yeah, and we have time for a couple. So please say who you are if you're comfortable doing so and ask your question.
I'm Senna. Thank you for the presentation. I think you mentioned data centers at the beginning, and I know that data centers use a lot of energy. So I was wondering if you have any ideas on how data centers specifically can improve their efficiency and sustainability with AI.
Yeah, great question. And yes, data centers are the factories of 21st century. Just to kind of put things in perspective, today data centers represent about 1 to 1.3% of the global energy consumption, okay? And this is going to grow significantly, probably going to double in next 5 to 8 years or so. What is also interesting is that the overall energy consumption of data centers has not changed significantly in the last 15 years. Since 2010, the overall consumption has been the same. So data centers, because they are the new kinds of factories, we have an opportunity to adopt new technologies, and data centers are perfect for controlling the energy consumption, because very few humans are there in that. You can keep them cool to temperatures that are most economical, and these are also outfitted in a way to really reduce their footprint. I mean, they are also in locations where you probably have less. So I think data centers will probably be the ones that we will be concerned, but I think they will probably have, they'll be able to manage the energy demands much better than, let us say, a steel plant or a glass plant that is converting.
Thank you for that great question. Do we have any other hands? I can see lady in the back there. Thank you. Put your arm, yep, that's it, so our roving mic can see. Thank you, roving mic, as well. Please say who you are and project your question.
Yeah, hi. So I'm Sasha, and I'm really curious to hear more about how specifically you can use AI to improve batteries and help in that regard there.
So the question was how to use AI to improve batteries. So this is one of the areas that we look into pretty closely on a couple of angles. The first one is on the management of batteries itself, because batteries are part of UPS and backup systems too in data centers, and they operate in difficult conditions. And the second one is about estimating the useful life. So one of the problems with all these batteries is to have like a right predictive maintenance. How do you know? How can you extend the life of a battery so it has got some critical elements that we don't want to throw away? So we can use AI both to operate the battery more effectively through BMS, as well as to extend the useful life through application of predictive maintenance techniques.
Thank you very much. Do we have, we have another hand. Sorry for neglecting this half of the room as well. I did realize I was over there. So yeah, a well-deserved question from this side of the room.
Hello. Kara Doriani Oshie, AI ethicist at Patron. My question is about sustainability in AI development. I want to know, from your perspective, what should we be doing as an AI community in terms of best practices to build AI in a way that doesn't generate so much energy? What are the most impactful areas? What should we all be doing and adopting into our practice as we move into the future?
Okay. Great question. Um, keeping the energy consumption of AI in mind. So, few things that we can do and we started thinking about. First and foremost is really thinking about the energy footprint of AI model. I mean, being able to measure. There has been effort recently on the so-called green IT, so we can start to understand what is the carbon footprint of the IT equipment that we use. So if you're starting to measure it, then you can manage it, right? I mean, that's the first principles of management. The second one is, in terms of the AI models, we know that the energy consumption is generally correlated with the complexity of models. The larger models that you have, the more computation that it requires. So there, it goes with, the Occam's razor principle. What is the, the simplest thing that, you can do to solve the problem? And there is also a side benefit of trying to find simpler models. Not only that, they have less energy footprint, they are also easy to understand. You can put a very complex deep neural network to do a forecasting problem, something that you can probably do with a much simpler algorithm. Or you could do some anomaly detections using regression rather than using, again, throwing a kitchen sink like a deep neural network on that. So I think thinking about the model complexity, which is generally correlated with energy, is one of the most easiest things that we can do. And in the long term, I think we will be measuring and monitoring the energy usage of AI. But my personal belief is that looking at the kind of problems that are in front of us and how AI can help, the net effect is going to be positive. I think AI will help us save more energy than what it is going to consume.
Thank you very much. The net benefit is positive. Please give a big hand to Sreedhar Sistu.
Thank you.
Thank you.